Hello, we're going to be going through the third unit of the trigonometric graphs, third section of the trigonometric graphs unit, and it's talking about phase shifts. So this is going to be moving those trig graphs around on the coordinate plane, not stretching them out so much, but now we're going to be moving them up, down, left, and right. So the graph of f of x plus c is the graph of f of x moved c units to the right when c is negative, and c units to the left when it is positive. So a negative c value is going to make you go to the right, which seems a little strange, and a positive c value is going to make you go to the left. Again, that seems kind of backwards because your positives are to the right, but in this case you're actually doing the opposite of what normally happens. The horizontal shift of a trigonometric function is called a phase shift, because the phase of the graph that is going down, for example, is being shifted to the right, and then the phase where it's going up is being shifted to the right. So each phase is shifting into the next section. That's where the terms come from. The other thing you need to watch out for is problems like this one, y equals sine parentheses 2x minus pi over 2. You'll notice that there is a 2 in the front here. You need to be careful with this because you actually need to factor that out. So if you were factoring a 2 out, you would pull the 2 out, so you'd have 2 parentheses. Well, I'm dividing this by 2, and I'm dividing this by 2. So I'll now have x minus, well, 2 and 2 on the bottom there is pi over 4, which is where it comes from over here. It says this is actually 2 parentheses x minus pi over 4 because you have to factor out your 2 on this side. So the graph of f of x, oh, sorry, that'll be in a second. So anytime you're looking at these phase shifts, you need to make sure that your x right here has absolutely nothing with it. If there is something, you need to divide it to the outside. Down at the bottom, the other thing is a vertical shift up and down. So the graph of f of x plus d, that d on the end there, is the graph of f of x vertically shifted d units, and then in parentheses up if positive, down if negative. So if you're tacking something onto the end there, which in this case they tack that d onto the end, it's going to shift either up if it's a positive d or down if it's a negative d. So we're going to jump right into example here. And I have set this up already just so I don't have to spend the time, just so I don't have to spend the time graphing it. So I've set up my axes here, and the vertical axes I'm going up by 1s. And the horizontal axes, I'm skipping 4 little boxes or 2 big boxes in between each of those. So you might want to pause this, take a second, and set up your axes there. I've also graphed the sine curve here because that's the curve that we're dealing with. So I didn't want to spend time graphing those, but that's the original sine curve. So pause this, take a second, and graph those. Alright, so looking at this graph now, there's several different things that you can see. You should be able to see that there's a number in the front here, which is actually going to be, I should use a different color than that. That's actually going to be our A value, or our amplitude, and in this case it is 3. You should also be able to see that there is a number tacked onto the back here, that negative 4. That's actually going to be our D value, which is negative 4. And in between we have a B and we have a C. So we need to figure out what each of those are going to be. And this is one of those tricky parts, again, where you need to look at what's here and say, okay, I need to get rid of that 2. So to get rid of that 2, you're actually going to go ahead and divide it out. So I would divide this by 2, and I would divide this by 2. So my new equation will be y equals 3 sine of 2x minus pi over 4. And you're not going to be able to see this on the end there, minus 4. So now we can see what our b value is. And in this case, b is out in front here, so it's going to be a positive 2. And our c value is pi over 4. So each of these means something a little bit different. So the amplitude, if we recall, is a vertical stretch. And b here, 2, is our b value. That's actually going to be a horizontal compression, because you're going 2 times as fast. You have twice as many curves in the time that you would normally only have 1. C is going to be our horizontal shift. And remember, it's negative pi over 4. So we're actually going to shift to the right because it's a negative, which again seems strange backwards, but we're shifting to the right. And that negative 4 is going to be our vertical shift. And it's a negative, so it's going to be down. Now you could graph each one of those separately. You could graph something with an amplitude of 3, then the horizontal compression. I'm going to do a couple things at once here. So the first thing that I'm going to do is I'm going to go ahead and I'm going to graph A and B at the same time. So I'm going to do a vertical stretch of 3. So now instead of going to 1, they're going to go all the way up to 3 and down to negative 3. And I'm going to do a horizontal compression so that there's twice as many curves in the normal span. So that means that at pi over 2, I'm not going to be at 1. Instead, halfway there, I'm going to do it. I'm going to be up at my maximum. So I'm still starting at 0. And now I go all the way up to 3, but I have to do it twice as fast. So up at 3, down to negative 3, up to 3, down to negative 3, and back at 0. So if I draw this in here quick, our first curve looks something like this. And you'll notice now that I have 2 full cycles. I have 2 full cycles in the time it would normally take me to do 1. And I have to remember that I need to go backwards as well, because the problem says from negative 2 pi to positive 2 pi. So I need to do both sides here. Okay, so that takes care of A and B. Now what's going to happen is I'm going to do my horizontal shift. I'm going to take care of this piece right here. So I want to shift pi over 4 units to the right. So I'm going to do this piece. I'll do it in green here. And I want to shift pi over 4 units to the right. Well, if this is pi over 2, then half of that is pi over 4. So I'm shifting one big block here. So instead of being at 0 here, I'm going to be at 0 here. And then you follow the same pattern. So instead of being at 1 here, I'm going to be at 1 here. And then follow the exact same pattern. And I'm actually not going to draw this curve in, because it's going to start to get really cluttered if you keep putting every little piece in. So I'm not going to draw this curve, but it would look something like this, right? And the reason I'm not is because this last part here, now I'm going to do my vertical shift down 4 units. And I'm going to do that and then draw the curve in. So now I'm taking each one of those green points and I'm going to drop them down 4 units. So I'm going to start all the way at the end here, and I'm going to go down 1, 2, 3, 4 units. So my new point will be here. I'm going to drop this down 1, 2, 3, 4 units. Each one of them is going to be dropped down 4 units. And you should be able to start seeing the pattern that now instead of going from positive 3 to 0 to negative 3, I'm going from negative 1 is my maximum, down to negative 4, which would be like my new center line, and down to negative 7. So if you go ahead and finish graphing that up, your final curve should look something like this. Actually, let me erase these little marks here. So your final curve should start down at the bottom, curve up, and it should look something like that. So your final answer is actually this blue line down here, doing that beautiful curve. And you should definitely make sure that you label it y equals 3 sine parentheses 2x minus pi over 2 minus 4. And I know that kind of ran off the screen there. I apologize. That's going to be the toughest thing that you're asked to do. And the nice thing is you could actually put that in your calculator and get some points, but it does get a little bit confusing. So if you know each of these shifts, it becomes a little bit easier. Alright, so the next question says write 2 possible equations of the graph shown below. So we're looking at this graph here, and there's a couple things that you should notice. First of all, it starts at a point in the middle here and goes up. So immediately you should be thinking that this is going to be a sine graph. And actually I should write y equals sine of something. So from there you need to be able to tell, okay, what's happening to this function? Well, if you're starting in the center here and going up, normally you would only go up 1 unit, but as you can see here, this is actually going up 2 units. So right away I could say, okay, well, if I'm going up 2 units, and then if you look in the other direction it goes down 2 units, this is going to be 2 sine, and then we need to figure out if there's any horizontal, vertical, or shifts or stretches or anything like that. You should also see down at the bottom here that our marks, there are 4 of them, which I know there's no labels. There won't be any labels on your graphing calculator, but they're always pi over 2, pi, 3 pi over 2, and 2 pi. So this is actually still just completing one cycle all the way to the top, all the way to the bottom, and back to the start. So it's still completing one cycle, so there's no horizontal stretch going on at all. There's also no horizontal shift going on because you're all the way at the top here, you're back to the middle, you're at the bottom, and back to the middle. So there's no horizontal movements at all, so we can go ahead and just put sine of x. The last thing that you notice, though, is that this center point is not at the origin. It's actually up 1, 2, 3, 4 spaces there. So this would tag a plus 4 onto the end of it. So that is the very first equation. So we've now written one possible equation, so now we need to write one more. So I'm going to erase all of my stuff off of here. Oops, that didn't work. And we're going to go ahead and figure out something else. Well, we know we can't use tangent, so our second choice is we can do cosine. Again, you should still notice that you're going up 2 and down 2, so we're still going to have that 2 out in front. And there's still no stretching going on. We haven't stretched anything, so we're still going to have just the x. But now there's going to be a shift. So we need to figure out, okay, how far has this been shifted? Well, normally it would start at 1 and go down before coming back up. So normally we would look like this. So the shift from this point to this point, shifting it forward, is going to be pi over 2. So this is going to be x minus, because we're shifting to the right, pi over 2. And then we still have shifted up those 4 units, so that's going to still tag the plus 4 on the end of it. And I know that's kind of tricky. The nice thing is, though, once you figured out the amplitude change, once you figured out the vertical shift, those are going to stay the same whether it's sine or cosine. The only thing that changes is this piece right here. That if you want to switch it from sine to cosine or cosine to sine, you're going to have that horizontal phase shift in there, putting something in the parentheses. The last question talks about a roller coaster track, and I would actually like you to take a second and try and figure out what A, B, and D are going to be. The one thing I would tell you is that you don't necessarily have to have a specific number of degrees. So this actually hits the bottom right at 400, and it's the maximum up here is at 200 and 0. So remember, A is your amplitude, so figure out what is your amplitude. B is your horizontal stretch, and D is your vertical shift. So those are the 3 things. So you need to figure out for me, what is A equal to, what is B equal to, and what is D equal to. And there is one thing I want you to add on the bottom of the page here, which is I would like you to add y equals A sine B parentheses x plus C plus D. And we're going to real quick just write down that A is your amplitude. B is your horizontal stretch. C is going to be your horizontal shift. So that's going left to right. And again, this horizontal stretch is stretching out left to right. And D is your vertical shift. So this is moving it up or down. And actually amplitude, you could rewrite that as vertical stretch. So it's stretching it up or down. So write that on there. It kind of gives you an idea that your A and your D, the two on the outside there, are your verticals. They're moving it up or down, they're stretching it up or down. Your B and your C in the middle here are your horizontal stretch and shift. They're moving it left to right. So make sure you add that into the bottom, and I will see you tomorrow. I'm sorry this is such a long video.